Let's continue talking about creating evolutionary design and architecture. We talked about what architecture is, what evolutionary means, what are some of the risks in not creating it, the economic impact of it, and what are some of the risks in creating it. Let's get into the details of how to really approach creating evolutionary architecture. There are so many things we can actually do to create evolutionary architecture. Thankfully, it's not as little as saying, well, you got to create an evolutionary architecture, good luck. No, there's actually things we can do, and I mentioned that creating an evolutionary architecture must be a very deliberate effort, and there are ways we can actually make it work. The very first thing we can do to create an evolutionary architecture is to keep it simple. Now, it turns out that simple is not really that simple, and Einstein is quoted as saying that any intelligent fool can create something bigger and more complex, but it takes a touch of genius to move in the opposite direction to create something simple. So the point really is, it actually takes more effort to create things that are simple. But what is simple? Well, the first thing is a simple solution is a solution that focuses on the real problem. It solves the problem as we know it. It solves the problem as we understand it. A simple solution is a solution that fails less. A simple solution is a solution that keeps our focus. It helps us to know that what we are focusing on, and it is easier to maintain, easier to evolve as well. But simplicity is not so easy to really attain. It requires a lot of effort to create it. We have this tendency to create grandiose schemes of things. We take pride in creating complex things often, unfortunately, but we really need to take pride in creating simple things. And so when it comes to creating things, why not just get away with just this amount of code based on what we know right now? Why can't we have simple data types? Why do we need a complex data type right now for what we are trying to do? And what does it provide to evaluate the pros and cons and then be willing to accept and use what is simple, and with knowing that you could actually evolve to something a little bit bigger if that is necessary, if that is important. So the very first thing is to actually keep things simple. And one way to make sure we keep things simple is to only solve problems that we really know are worth solving. If something is not worth solving, then don't solve it now. Postpone it until it is really important to solve it. And so you can keep the focus. And simple is something that removes unnecessary details, peripheral things that often interfere. One other way to make things simple is to keep independent things really separated from each other. This is one common mistake I see programmers, including myself, do quite often, is bring two separate things into one, and that bringing two orthogonal things into one increases the complexity of the code we are writing. If two things are definitely independent of each other, it really helps to keep them separate rather than mixing them together in one single place. So when it comes to designing your classes, designing your data structures, deciding where to put stuff, we would always say, oh, I could group all of this so I could be very concise in creating all these things in compact one place. But that may actually be really detrimental, because eventually the needs of these two things diverge, and that piece of code becomes really hard to maintain and evolve because they tend to change at different frequencies. So by keeping things cohesive, we can make things simple as well in that process, because when two different disjoint things are kept separate, they evolve independent of each other, and as a result, it becomes easier to evolve and becomes economical and cost effective as well. Refactor with vengeance. One of the slogans is make it work and make it better real soon, and refactor the code quite a bit along the way. Frederick Brooks in his wonderful book said, go ahead and develop a software, and when you are done, throw it away. and then start building it again, you have a chance of coming close to implementing something that's meaningful and valuable. Well, the point really is, if you go to your boss and say, I've got a great idea to develop better software, we're going to build this, and when we are done with it, we're going to throw it away. Well, that's the easiest way to get fired from the company, isn't it? So it's impractical to build a massive software and throw it away, but does it mean Frederick Brooks was wrong? Well, Brooks was absolutely correct, but then how do we really take his recommendation? Why not throw away the code, not the entire project, the entire application, but throw away every little piece of code we develop? And this is something we need to be willing to do. It's really fascinating to think about it this way. We as programmers sometimes are so misconceived in our notions that we think we will sit down and write code once and be done with it. If you look at great artists, they created and recreated and prototyped before they arrived at masterpieces. In the same way, if you have an idea, implement a piece of code, and once you have it working, throw it away. That little piece of code, a little function, refactor it, make it better. And then we have something we can work towards making evolutionary. So when you build a piece of code, then you say, are these coupled too heavily? Maybe I should refactor this to decouple them. Oh, you know what? Better than decoupling, this dependency shouldn't be here in the first place. If I remove this dependency and pass the data this particular function needs, I don't need to decouple. I have removed the dependency. That's a refactoring I want to do, not decouple, but really remove the dependency, eliminate the dependency rather than invert it. And these kind of decisions we can make during the refactoring times. One other thing we should be very careful about is this very important concept of reversibility. One major thing that contributes to our ability to evolve an architecture is reversibility. What is reversibility? Reversibility is the ability to back out of a decision that we have made. Let's say for a minute that I have an application. I've decided to use a particular library for processing XML documents. Well, my XML documents I'm processing with them, and everything seems to work just fine until I come to a point where I realize that some of the XML documents I'm dealing with are either way too large or relatively complex, and this library is not giving me a really good ability to parse them, at least not effectively. Now, what is the cost of reversing out of the decision to make that XML parser and substituting that with another parser? Well, if the cost is prohibitive, where you need a lot of time and effort to make this change, then you're going to be very reluctant and you're going to be committed to continuing with what decision you made, and in the process of doing that, we begin to suffer through the consequences. But if we had developed the application in a way that our dependency on this parser is rather relatively modularized, we have a class that, or a piece of function that talks to this parser, but the rest of the code doesn't know about this parser, that is fairly tactical area where we can rework, remove this parser, bring in another one, and integrate the code with that parser. Rest of the code is not impacted. Run all your automated tests. Notice tests make a difference here because it gives a very quick feedback that when we made a decision to revert back and change to something else, things that worked before are working now. The fact that you decided to switch between one parser to another shouldn't break your entire application, but how do you know that? You want a quick feedback loop to know that, and that's why automated testing comes into picture as well. But you can reverse this decision. Yes, you decided to use parser XYZ1 about 12 months ago, but now you decided that's not the right parser for you. Maybe that parser is no longer being maintained in the marketplace, and maybe nobody is developing that anymore, and there are huge bugs that are just left unfixed. But there's this other library that's far better library. I want to reverse out of that decision and use this one, but I want that to be cost effective. So reversibility is extremely important. But sometimes we don't realize it. I'll give you an example of reversibility or the lack thereof that I learned very early on the hard way. In one of the projects I was working on, this was decades ago, we were using an object-oriented database. I won't mention the name here, but this object database, when I joined the project, this application was using an object-oriented database. And as a developer, a very young developer, I didn't know a whole lot. I just started working on this project. Hey, this is really cool. This is awesome. Hey, how do I really implement a persistent object? Oh, Venkat, that's very easy. If you want to create a persistent object, you inherit from this base class and you implement the code. Oh, that's awesome. Here, public class and inherit from this class and I'm done. Well, about 6 months went by on this project, and by this time I had gotten comfortable with the project. I knew what things are, and as we started developing more and more code, I was very comfortably developing applications on this particular object-oriented database at this point. A good year goes by when the database vendor made a very substantial change. Now, remember what I just mentioned. To create a persistent class, I would say my class, and then this will, I'll just use a language agnostic syntax here, inherits, let's say, from, which is not a syntax in any language, and it is going to be a persistent, let's call it base. Well, this was required. Notice one big problem that you see here already. We are using inheritance, and inheritance is one of the most static coupling, type coupling that you can think of. Well, a year into this project, the company that did the databases decided to make a substantial change to the persistent base. They re-implemented this, and by making the change in the next version of the database, every single class in our application was dead in the water. We had to go back and change every single class in our application for us to be able to move forward to the next version of this database. And I learned this lesson the hard way. And what happened in this case is our application surface area was so big that every single piece of the application touched directly the database tier. And as a result, every single or most of it, if I would say, and as a result, the impact of change to the database library had a direct impact on a very big surface area. Lesson learned. It took us close to a year to make change to our application for all the impact of this change, because we had a very large application we were working with. And to make all the change and make sure everything worked. And these were the days when we didn't have any automated testing. And we discovered so many compatibility issues and things did not work. The code would compile eventually, but then the fun really started. So the point really is the decision here to reverse out of this database. One of the key people in the company came to us and said, hey guys, I got a question for you. If we decide not to use this database vendor and we decide to use some other database, what would it take? And we all laughed. And then we laughed a little bit more and we said, you got to be kidding. You're not serious, right? Well, the reason is that changing this database would be the death to our entire application, because every single or most of the classes had a direct inheritance at the core application level. And that's a lesson I learned the hard way, that the coupling was so deep that we cannot reverse out. We were married to this database forever. And if this application would ever have to reverse out of this database, it would be economically unrealistic to be able to do that. Now, of course, I know better. I don't tie myself to databases that way. And I can reverse out of decisions quite a bit. And I'll tie this to the next part of a last responsible moment as well with another experience I had. But reversibility is extremely important. So when it comes to making a decision, there are certain decisions that are really hard to reverse. For example, if I go to an application and say, hey guys, you are using the language that you are developing this application, you've been doing this for 3 years, I want you to throw that away and code in a completely different language. That's not reversible. Language decisions are not reversible. That doesn't mean if you're developing in C#, you cannot develop components in F#. Sure, you can. That doesn't mean if you're developing application in Java, you cannot have parts of the application in Groovy or Scala or Clojure or one of the other languages on the JVM. Yes, you can. But you cannot completely throw out the language that the application has been predominantly developed with and bring in a new application. That's just not possible to do. But having said that, we can certainly make decisions that some decisions are reversible and others that are not. If a decision is reversible, remember there's a cost of reversibility as well. If you want something to be reversible, you got to decouple from it. You got to contain the surface area to be a very small area of contact with that. And you should be able to design for reversibility. So there's a cost of reversibility and there's a cost of non-reversibility. And it's very important that you should only make things that are reversible that deserve to be reversible. Making everything reversible is going to be cost prohibitive. For example, I don't want to decide which language to use. I should be able to pick and choose any language I want moving forward. That is insane, at least for what we know today. What you would end up doing is you would end up creating your own proprietary language if you don't want to rely on any language, and then you end up taking your proprietary language and converting it to one of the other languages. Believe me, companies have done this. And when we do it, now we have a other set of problems. Now you're creating a language you have to maintain. And when the languages you convert to don't have the same compatible feature, that increases the complexity of your language you are creating. When the language you are binding to evolves, well, that's a nightmare you got into. That reversibility is way too expensive. The cost versus benefit doesn't hold in that case. But we all can agree today, based on what we know so far, that you don't want to commit to a particular database. Even though, how many times you see this? Go around and talk to projects. You would notice that people will say, oh, of course we can use any database. And then they will tell you they got stored procedures that are written specifically to a particular database. Oh, my product will only run on SQL Server 2000, 5, or 2015, whatever that is, right? Well, but why are you depending so much on this particular version of Oracle 9.0? Well, what if I bring in this other database? Can you run with some other database, DB2, MySQL? Well, no, because we got stored procedures that are very specific to this database. Well, I'm sorry, you don't have reversibility in this particular case. So the point really is, just because somebody says there is a reversibility, don't assume it's actually reversible. The question is, have we really developed it in a way it is reversible? So there's reversibility in concept and reversibility in reality. A database is reversible in concept, but did we really commit to decisions that make it irreversible? That is something for us to think about. So don't make everything reversible. Ask if something should be reversible or not, and if something is useful and important to make reversible, then make sure it's implemented as reversible at the architecture and the design level. Just because something could be reversed doesn't mean we want to make it reversible. And just because something is reversible doesn't mean it's been implemented in a reversible manner as well. But reversibility is extremely important decision to make. But if we do decide that something has to be reversible, or then we should make sure that we have actually implemented it in a way that it's reversible. If something is very hard to reverse, postpone that decision to commit to it as much as you can. Language is one thing I would say. A language is very hard to reverse, so postpone the decision to commit to a language as far in as you can. In the beginning of the project, if it's worth it, take the time to experiment with a few languages and say, let's see which one is suitable for this. Maybe I should use Groovy for this. Maybe I should use Java for this. Maybe I should use Ruby for this. Let's experiment a little bit in the beginning and pick and choose, not based on emotion, but based on technical merit and practicality. And of course, the availability of people as well can counter to that decision. So the point really is that if something is very hard to reverse, commit to it as late as possible. If something is worth the reversing, then commit to reversing it and build it in a reversible manner. That is very important. And keep in mind there's a cost of reversibility as well. Then comes along the last responsible moment. A last responsible moment is to postpone decisions. Ken Beck says that courage is postponing the decisions of tomorrow to tomorrow. How many times have we made decisions way too early, committing to things when we don't have to commit to things? So at every level, at the strategic level, at the architecture level, at the design level, at the parameter level to a function, every single way, see if you can postpone a decision, and if you can wait to make the decision later, wait to make the decision later. Now, why is that? Well, the reason is we know more about something later than we do now. We can all agree, right? If you go around and ask people, are you smarter today or are you going to be smarter tomorrow? Well, most people will tell you they're going to be smarter tomorrow. I say most because I've actually come across people who say they're going to be smarter today than tomorrow. You kind of makes you wonder. But the point really is that we are smarter tomorrow than today. Why? Because we get to know about the context a little bit more as time goes on. We got more information. Things kind of filter through and resolve as time goes on. So we know more of the context as time goes on, and we are able to put things in perspective as time goes on than we had in the beginning. So when you have to make a decision, postpone the decision to the last responsible moment. It is like things that I want to do. Like, for example, I enjoy writing. I enjoy writing code. But that doesn't mean I should just sit there and keep writing code. I should only write code that provides business value. But of course, if I really like writing code, I sure should spend the evening writing fun code for learning experience and fun projects. But production code is different. It's got to be something that I deliver value for. And I have to really know when to implement what feature. And I'll give you some examples of this. And I was developing an application where I had about a slew of features I wanted to build. I went to some of my friends and I said, here's an application I want to develop. I want to put it in production. Here are the features. What do you think? And they all gave me input. They all evaluated it. Then I went into production. And once I released it, I asked the same friends to look at it and give me their input. And one of my friends came back and said, wait. You originally said, here are the list of features, and I only see about half of those. The other half of features that you mentioned are quite interesting, but I don't see them in the product. What's up with that? And I said, I decided not to release those features because I can start making revenue, I can start improving the product, I can get this better, and then once this is in the market, I can come back with another release to add those features. And that's exactly what I actually did. I deployed the product and I waited for a good year before I implemented and released another substantial feature into the product. And then within about a month, another, and another month, another. But this was very rewarding because what I had there started producing revenue in the meantime. What I had there started giving me feedback in the meantime. And I was able to see real usage and start delivering value where there is value to be delivered rather than hypothetical things that I was thinking about. This is last responsible moment for a feature level. Similarly, at the code level, little decisions we make, we should be able to postpone to the last responsible moment. I'll give you quite a few examples of this. Filing taxes. I always want to file my taxes on the very last day. At 11 p.m. April 15th, I sit down and have a conversation. Dear Lord, if I'm going to live for another hour, let me know now. I can spend the time filing the stupid tax return. That's last responsible moment. Why would you want to waste your time doing something that you don't have to if you're going to be gone? Well, okay, just kidding. But the point really is postpone until the last responsible moment. I'll give you an example of this. I was developing an application which had a very heavy use of persistence. Every single data that I gather from user interaction has to be stored in the database. This is predominantly a database application where data is stored, data is manipulated, data is modified, updated, added constantly. Every minute this application is running, I'm going to be dealing with the database. So you would say, oh boy, then the database is very important, right? Yes, it is. But the database is important, but not the database implementation. And honestly, I took a very bold but a very nervous step. It took me about 6 months to develop this application, but when I started developing this application, a lot of things were important to me. One, to really start building valuable features, to be able to automate the test very quickly and get a very rapid feedback loop of these test runs. I want to be able to change my data model constantly. While in the beginning I'm evolving the code, I want to be able to say, here's the data model I want to work with. Oh, 2 days later, I have a better idea. I want to have that flexibility, especially in the beginning. So here's what I did. I went out and picked SQLite as the database. Now, clearly, you would not deploy your application using SQLite. No, you cannot. But the point is, I used SQLite. And for that 6 months project, until about 3 weeks before I went into production, my application was only using SQLite. Was I nervous? Sure I was. But I had developed this with SQLite entirely, and now came this last responsible moment. I can no longer postpone the decision of what database I should really use. But here comes the good news. The fact that I postponed the database decision paid off really well, because I had to really pick and choose the cloud environment where I'm going to deploy the application. Honestly, 6 months before that, when I started developing the product, I had no clue. During that 6 months period, while I was developing the application, I was also evaluating where to deploy this. Do I want to deploy on vendor 1's cloud, vendor 2's cloud, vendor 3's cloud? What are their pricing models? What are their regions of availability? What are their reliability model? All of those things are considerations. And by this time, I had made a decision as to where to deploy it. Now the question is, what kind of databases are available on that cloud? And now that I know what databases are available and I can easily install and upgrade it, now I had a decision as to which database to deploy. So 3 weeks before deployment, I came to work one morning, removed SQLite, put in this other database locally on my machine, of course, and ran. Now the question is, what if some things don't work? Well, here comes the good news. I had 100% coverage of test cases. Of course, not everything was unit tested, but I had 100% coverage from unit test, functional test, and integration test. So I took away SQLite 3, put in this production type database, and then I said, run all my automated tests. Well, I had thousands of automated tests at this point. When I ran all my automated tests, 3 tests broke. Immediately my pulse rate goes up. Oh dear, what do I do? It doesn't work with the real database that I want to use in production. What do I do now? Well, I immediately look at the error message. I literally copied and pasted the error message into Google, and immediately the first link there says, oh, this particular string has an incompatibility between these two different databases. This database requires this length, this one doesn't care about it, this other database cares, this one doesn't, and a list of databases and the problem related to it. And the minute I saw it, I'm like, oh, of course. And I went to my database schema, modified the size of that particular string, because apparently there was a limitation. One database grew with the other one didn't. And so I modified the change to that one data type, ran all my tests in SQLite 3 one more time, and guess what? All my tests passed. And now I ran all my tests in the database that I was going to use in production, the type of database, and all my tests ran, commit the change to the code, and off we go. And that was the last day I touched SQLite on that project, but I moved on to use this other database, and of course it's been in production, and that's the last responsible moment I decided. Now, why did I decide to postpone something as critical as what database I'm going to use in production? The reason I postponed the decision is, A, I don't want to work with the real database. I want something very lightweight, something that I can blow away, a file-based database, SQLite 3. I can just say, poof, go away. There's no process. There is no database engine running. I can just blow away this file and recreate it any number of times. And it's very lightweight. And I don't need to really do any setup and configure things. It becomes easy for continuous integration purposes. And then, of course, I don't want to know what database to use, because if I started coding with one production type database today, I don't know what I'm going to use in production really, because that decision as to the cloud environment I'm going to deploy has a bearing on what database I would end up using. I want to be able to pick and choose the right one based on other various things that I talked about in terms of what would lead me to select the cloud. And then, of course, within their confines, I have to make the decision. And you may argue that most prominent databases will be available in most of these cloud, sure enough, but pricing model may be very different though. And so you may want to postpone the decision, and that is about last responsible moment. So when it comes to making decisions, one of the most important decisions we have to do is this. So let's say one of the most important decisions is what to decide and when to decide. So this is something we need to keep in mind. When do we really make this decision? If I don't have to commit to this decision now, it's better to postpone it until later time. Like, for example, when I book for travel, flights are usually very expensive, so I may book an international flight about 4 months or 3 months before my travel internationally, if I know the travel for sure. But if my travel is really iffy, I might buy a bit more flexible ticket so I can cancel it. If I know for sure this travel is going to happen on that day because it's a very important conference that's confirmed, I would buy the ticket fairly early. But what about the hotel? What about the car? I might postpone the decision to a few weeks before the travel. What about a dinner meeting with a casual friend? I might even decide that when I land over there. So the point is, there are decisions we make early on because making those decisions later on is expensive. There are decisions we make later on because making those decisions sooner becomes actually expensive, and it's easy to make those decisions later on when we know more. So ask yourselves, what is the cost of making the decision now and the cost of making it later? What's the benefit of making the decision now and making the decision later? If it doesn't have to be decided now, postpone, and now focus on what cannot be postponed, what has to be done right now. And so the last responsible moment is a very important way to approach evolutionary design, and that gives an opportunity for us to evolve things as we understand better. Well, I'm going to end the part 2 right now, but we're going to talk about a lot more of these in the next few parts.